On the bench today we have basically a blown up power supply. So this is let me show you the front panel of it. It's an HP 6023, which is can be used as constant voltage or constant current, but it's from 0 to 20 volts and 0 to 30 amps. Now, before anybody asked, no, it will not do 30 amps at 20 volts. You have to take this into consideration right here, 200 watts. I know some people have been burned by that. Occasionally they'll buy something like this, a laboratory, working, not one in this condition, but, they get a laboratory power supply, an extremely expensive power supply, top of the line quality, and thinking it's going to do all kinds of amazing things, and they get it and find out at the voltage that they want to use it at, it might only do half that current, or something like that. It can do full current at lower voltages. So, it can do, you just need to remember, it can only do a maximum of 200 watts of power. So, I mainly work on two-way radios, so, probably if you're watching this video, good chance that's what you want a power supply for. Something like this one, that would work out to what, like 17 amps? Somewhere around there, I guess. Yeah, I'd have to do the math, but just quick in my head, I guess I'd be probably somewhere around 17 amps at 13.8 volts. But anyhow, I got this power supply, was supposed to be working. Got it, turned it on, the fan motor, which is way back there, that's the black thing right there, that's actually the back of the power supply. The fan came on, good fan, no, actually, it's a good extreme, like I say, this is an HP, so, it's a really high quality fan, it's actually rather quiet, but the fan spun up, but that was it. No display, the voltage and current displays were not illuminated, and none of the LEDs, so, either the constant current or the constant voltage, basically completely unresponsive. Push buttons, you weren't getting anything. So, I contacted the person I got it from. I said, I can take it apart, take a look at it, and see if I can figure out what's wrong. As soon as I pulled the top cover off of it, which is right here, this is a rather long beast. They're good size. And then actually you have that, and you have the bottom is its own little piece with the feet. And then there is a internal chassis, which is what this actually mounts to with a bunch of screws. There's actually 4 screws in each transformer and a bunch of screws down through the board that actually mount it to this substructure. And then sitting on top of that substructure, when you first take the top cover off, you see this, which has some of the information about the power supply and the adjustments for when you're when you're calibrating one of these. But like I say, calibration potentiometers ain't going to do me much good, because when I turned it on, it didn't do anything. So as soon as I got the main top cover off, I could instantly see what's wrong, and you can see it in the camera. You may not realize it, but it's there. It's that transformer all the way in the back there, it's broken. Yep, it got damaged in shipping. So actually, if I flip this around, you can actually see what they have is a plastic, normal iron core transformer with several windings, because these are actually FET drivers. That's actually what they're attached to. It's actually what they call it in the parts manual, I think, is FET driver transformer. But they have the iron core is encased with this plastic bracket, and then it has 4 screws. There's, one on each corner. Well, what happened was this broke. The transformer tilted forward, and it snapped off every single wire. Now, there's only 3 on the front, but there's a bunch more on the back side. And it snapped every single one of the wires off. Now, I'll never get the camera angle just right because of the location of some of these other components in here. It's actually hard to see down in there. Even with all of the other stuff out of it now, it's still hard to see down in there. But from what I can see, it looks like the wires broke off flush right here, because there's really not much wire sticking up off of the terminals right there. So I told the seller, there's a possibility I can most likely fix this, as long as I can get the transformer out. There's enough wire off of these leads, because the windings come around. You can see they go down through these little chases right here. as long as there's enough wire remaining that I can solder a new piece of wire too, strip off the enamel coating on it, solder on a piece of wire, and then bridge it back over, push the pins back up into the plastic in the bottom of it, and get my new piece of basically jumper wire soldered in there, it'll work just fine. It's just a matter of, can that be done? So that's where I'm at. So let me see if I can get this extracted now. So basically all I need to do is basically, actually the transformer will fall out once I desolder these front 3 pins, because all the wires are broken off, all the ones in the back. And the pins are actually, that's why the transformer is actually still rocked forward. The pins have actually pulled out of this bottom piece of plastic. So let me fire up the desoldering iron. I'll get those 3 extracted. Then once I get it out, see if it looks salvageable. If not, I got somebody that may have a couple of these power supplies at work in their laboratory that I might be able to get a good transformer out of for parts. But I told him, I was like, just hold on, let me try and see if I can fix this one first, because I've actually had to do that before. Had transformers where the wires were broke off or the pins got pulled out. And yeah, like I said, as long as there's enough wire there, that's actually a fairly easy fix. It's just a matter of, like I said, clean off the enamel coating, which I'll actually show doing that. So let me get it out of there and we'll take a look and see if this thing can actually be salvaged. So I'm going to say definitely repairable. I've already wrapped a wire tie around it here. I'll never get that re-glued. I probably could re-glue it, but I'd always be worried it's just going to break there again, because that's actually under a lot of stress. It's very springy, and it kind of snaps down in. See how they have the little dovetail there? So they put these things over top of it, and then they're pressed in, and it's probably a machine that does it anyhow. But yeah, there's a lot of stress on that, so yeah, it's just as easy. They have these little ears here, just rather conveniently, that are spaced just above the top of the transformer here, so you can put a wire tie across there, and that'll hold it together, and then there's still enough downward pressure here, because it's not like I'm going to be using this thing in an aircraft flying upside down. It's going to be sitting on a laboratory bench. So yeah, I'm not going to be shipping it to myself. It's not going to be bouncing through the shipping carriers again, probably ever again. I've already pried the wires up. There's, because of the enamel coating of the glue they have down in there is kind of down in there, but you can see the little green wires sticking out the bottom there. So now all I need to do is just take a little bit of that enamel coating off of there, and what I'll do is I'll just solder on I'll make little loops using that same gauge of wire, but what I'll do is I'll take probably a pair of tweezers is what I usually do when I'm doing stuff like this. You just take a pair of tweezers, actually, so you know what the heck I'm talking about. I actually did this to a microphone cartridge yesterday, so I actually have some really fine wire in here I was using for that. But the same token, it'll be heavier wire that I'll be using for this, but the principle is the same. You just take a piece of wire and then just make a little loop on the tip. Basically what you want's a little circle. That's just too small to even see, isn't it? But anyhow, you make a little loop on the end. Actually, it'd probably be easier if I just used a heavier piece of wire to demonstrate what I'm talking about. I just basically make a little loop like that. Okay, it'll be a lot smaller, but that'll slide over the wire, then I'll crimp it. I'll solder the connection between my jumper wire and the wires coming out of the transformer, and then that wire will then be what I'll actually wrap around the pins and solder these pins. So I still have to extract the pins. You can see they're all still in the board. So what this side is supposed to look like is that. It should look like that with all the pins. And I was wrong, there wasn't 3 pins on this side. As you can see, there's all of these other windings behind it, so I had desoldered all of those as well. But yeah, once I got those desoldered, the transformer just popped right out. So I just need to desolder those. I'll actually remove all of the wire that's currently on those pins, so they're just bare pins again. I will push them back down in to their little holes on here. Then I'll do my repairs, and yeah, I don't see any reason why this shouldn't work. Should be a fairly easy fix. A little bit time consuming, got to dismantle the whole power supply. just to get this board out. I mean, literally have to take the whole thing apart just to get this board out. But yeah, it shouldn't be that bad, so it should be repairable. So, I'll probably come back after I get the pins in and get it soldered up, so you can actually see what it looks like in here. And it's just so hard to see down in there because everything's dark. This is black, this is dark. You know, this transformer body's brown. The wires are so tiny they're really hard to see down in there. But yeah, luckily none of them broke off up in here. They all snapped off flush with the bottom of the I mean, just perfectly flush with the bottom of the transformer. So I couldn't ask for a better place for them to break off. So next time I'm back, there should be pins in there. That should be all back together. And then next thing will be just to pop it back in there, reassemble the power supply, hit the power button, cross the fingers, and hope we have display and voltage output. Okay, so we have pins and wires again. Have pins on both sides. So like they unsoldered the pins, took all the old wire off of the pins, pushed them in, stripped the enamel off. And in case you don't know how to do that, I just use a little propane torch. The camera wire is going to get in the way here. Joe can grab it. I just fold the wires up and then take this and, you know, just really quick, just kind of like that back and forth, and it'll burn the enamel coating off just the end of the wire. And then to make sure the copper is good and clean, I mean, you could use anything, piece of sandpaper or a razor knife or something. I have these little Norton diamond hones, and just kind of hold the wires on there and pull it over to clean the wire really good. Like I say, just wrapped some little pieces of wire. Just took a normal piece of stranded wire that had tinned wire in it already. You know, strip off a good chunk of insulation, and there's the wires I used. So, you know, and these are the same gauge as these wires. So for ones that had 4 wires, that's what I used. I used 4 wires, twisted them up, soldered them. Ones that had a single wire, 1 wire, and the ones that had 2 wires, I used 2 wires. I mean, pretty simple. But now what I'll do is, because of course when these were done, they put the varnish on them, and the wires, you know, when I took the wires out of these little pathways right here, I really had to pry them up because they were down in there with the varnish. So what I'll do, I'll just put a little bit of fingernail polish on there just to kind of make everything good and solid. I'll get the transformer popped back in there, put the entire thing back together, minus the top cover probably, actually the 2 top cover plates. And I'll be back, and we can find out together if it lives or not. I'm going to say yes. That's the only thing that was wrong, so no reason it shouldn't work. And we've saved a very expensive power supply, because even used, these things can go for a lot of money. So, you know, I'm not going to let something as simple as a transformer, you know, put a coffin nail in this transformer. So I'll be back, and we'll see if we can get some life out of this critter. Okay, so it actually works. So, saved from the scrap heap. Power it on. I'll just have a 75 watt adjustable power resistor here. It goes from 0 to 10 ohms. I've just got it somewhere there in the middle. I got the voltage set to 20 volts and current limit. Actually, see, it's the one nice thing about this style compared to cheaper power supplies, like a lot of the Chinese power supplies, and I use them, and there's absolutely nothing wrong with them. They actually work rather well. The only problem with those is to adjust your current limit, you have to short the power supply leads. There's no way of just, you know, hitting a button or, you know, and looking at the display and just turning the knob. You actually have to short the output of the power supply and adjust your current limit. With something like this, you know, HP, higher quality, yeah, you just push the display, set your current limit to whatever you want it at, and you're good to go. So, like I say, got a 0 to 75, it's still a little bit warm, 0 to 10 ohm 75 watt power resistor, just the first one I grabbed off the shelf, and I also have it hooked up. I doubt you can see it. Nah, you can't, just a blur over there. It's because I don't have the display inverted, but might be able to see the spark down here when I hook this up. You see a little bit of electricity going there, but there we are, 20, turn it down just a hair there, 20 at 3.1 amps, and oh, just see what it's at. Yeah, 200 and that'll go up the longer I'll leave it hooked up to this. Oh yes, we're starting to cook there. Yeah, man, we're cooking now. Yep, so she seems to work just fine. So now I actually need to dig out my laboratory load and actually put this thing under full load and let it cook it. Outputting 20 volts at basically let it at full rating at 200 watts and give it a torture test for a while. Let it run for quite a while at 200 watts just to make sure everything's working okay. But yep, seems like basically reconnecting all those poor little broken wires off of the transformer actually fixed it up. So there's a good power supply to stick on the bench now. I might stick that on this bench. Yeah, I might. I could take that other laboratory supply I got and stick it over on another one. This is a little bit smaller. It's the problem. I've got some monster laboratory supplies. I've got 2 of them that do from, I think those are 0, well actually no, one of them 0 to 20 at 50 amps. One does, and that's at full current. It'll do 50 amps at 20 volts. I've got another one that's 0 to 50 volts, I think it is, at 80 amps. But like this one, that one derates. So that actually has a chart right on the front of it and shows you the once you get to a certain current limit, it's the same thing. It's limited by a current, so you can't do the full 50 volts at 80 amps. Once you reach a certain voltage, the current starts to drop off. I've got another one that does, I think that one's a 30 volt at 50 amps. The problem is all of those things are huge. They're like 2 to 3 times the size of this. This one's kind of, it's got the height, but it's not as wide, because those are full-size rack mount, but they're also this high. So this one takes up like, a little bit less than half the space of any of those things. Now I do have a Sorensen. I think that one's also a 20 volt 50 amp one. But and it's only like that tall. But the problem, it's actually, I think it's even longer than this thing. I mean, shoot, this thing, it goes way back there. The problem with that is not only is it really long, it's also rack mount. That's why it's only that thick. It's it's a pancake. But yeah, so it takes up a lot of space this direction and back. But it doesn't take that much height. This one's perfect for sitting on this bench. So yeah, I think I'll probably stick this one on this bench. Because actually that supply I'm using now can't do as much current as this one, so the only thing I'll need to do is that one has outputs on the front of it, and I don't think there's any way to put outputs on the front of this. It's pretty much all circuit board in here. There's really, well, no, actually I think right in the middle here, now that I say that, there might be enough room to stick a double banana plug right here. I'll have to tear the faceplate back off. That's only 8 screws that hold this faceplate on. I'll have to take that off and take a look at it. I might be able to stick a double banana jack here, and that would save me. I'll still run cables off the back for higher current, but occasionally, if I only need to use something like this, smaller, thin wires, that way I don't need to be running off of big wires coming off the back. I can just plug into the double bananas on the front. But yeah, so if you ever do see this on this bench here, it might have double bananas here. I might do a slight modification to it. Just run a pair of wires. The only problem, I got to run wires in from the whole way from the back of the unit internally, the whole way up to the front here. But that'd just make it a little bit more convenient to use on the bench. Either that, or I'll just run another outlet box here somewhere and just mount, there's lots of little cracks and crevices around here. I could just mount a little double banana plug somewhere. Actually, that might even be more convenient. That way, the jack will be right in front of me. I won't have to go the whole way over to the power supply. So, but there you go. So, a successful repair on a HP 6023A DC power supply. Transformer was pretty much falling out of it. Got all the wires resoldered back on, and it's good in working condition now. And I checked voltage and current, both Don't even need to do a calibration on it. Alignment seems to be dead nuts on. I checked. Actually, there's one thing I do need to do is actually the voltage measurement is correct and the current measurement. They both read dead on. I've already checked those. The only thing is the current and the voltage and the current go up too high, because this is a 20 volt at 30, maximum 20 volt at maximum 30 amp supply, and currently it'll output up to 21.1 volts at, and you can see it just flashing there. So yeah, it's hovering right at 32 amps. So I need to bring that down. The maximum current and the maximum voltage, I do need to turn those down. And it's possible somebody may have turned those up at some point in time, because I own several power supplies like that, where companies will get something like this and they need just a little bit more, so they'll just go in there and they'll just crank up the maximum voltage or the maximum current ratings, figuring, well, we're not going to be using it at that really high level for extended periods of time, so we'll probably won't damage the power supply, but then that gives them a little bit of reserve, if they need it. But yeah, I'd rather just run it at what it's rated for. That way you never have to worry about exceeding that. You don't have to worry about burning parts up. It's kind of like a radio. Don't hot rod radios. Same thing with power supplies. Don't hot rod power supplies. If it says it's supposed to do 20 and 30, it should be 20 and 30, not 21.2 and 32. So there you go. Just another little repair video.